Dear students, in this presentation, we'll discuss some of the topics of Module 2, that is the linked list. The topics to be discussed are what is list, what is linked list, what is single linked list, chains, how to create chains in C programming language, linked stack and queue, polynomial representation, and polynomial addition. So for this presentation, I'm referred the textbook Alice Horowitz and internet source. Linked list. Like in case of arrays, where each and every elements are stored in contiguous location. Like suppose this is a memory location and there are 5 elements that are to be stored in the memory location. Okay, the first element of that array will occupy this place. Let us assume that address as say 1000. If that element is of type integer, then it requires certain number of bytes. Say let it be 4 bytes. The 4 bytes of this 1000, 1001, 1002, 1003 are taken by this particular element. The next address will be 1004. So I can guess what is the address of any of the element. There is a relation because all these are stored one after the other, contiguous location. The problem with this is you have reserved a lot many number of locations. Like in C, we have got this type of notation to declare array. Say 1000. In many times, we will not be utilizing these 1000 location, 1000 data. We don't have the data. So the allocated memory getting wasted. The remedy, the solution for this, go for dynamic allocation. Based on our requirement, get the data. For example, right now I need 5 locations. What I'll be doing, I'll be getting those memory locations using memory managing functions like malloc or cloc. I'll be acquiring that one. Then I'll be keeping the data in these nodes. These are all scattered. The address of these are not a linear, but I have to form a list of these elements. This is the first element, this is the second element, this is the third element, this is the fourth element, and this is the fifth element. Now I can't say that this is a list because there is no relationship between these things. Either in terms of the index, like the first element, second element, like that, or in terms of the address. There is no relation. Now I have to set some relations. How? Now the modification to be done is making use of pointers. This node has got pointer that I have to store it here. That a node should have the address of node following it. So this is the pointer field. This is the data as usual. This is the pointer field. Pointer definition is that pointer is a variable which holds the address of another. Here which holds the address of another node, like that. Here also I should hold the address of the next node. Here also I should store the address of the next node following it. Here also I should hold the address of the next node. As I don't have anything, I should mark that as null, means that no element is there. This is the concept of the linked list. A linked list is a random access data structure. The meaning is that I can get any of these locations. I can access these locations. I can add or I can delete randomly again. I need not start from the first locations. I can get any elements. That is a random access data structure. Each node of linked list includes the link to the next node. This is a link. This is the link which holds the address of the next node. A linked list is a linear data structure that consists of sequence of nodes. Like this is the sequence of nodes. Here I'm not telling the linearity in terms of the address. I'm telling that linearity in terms of the arrangement. The first element, second element, third element, fourth and fifth like that. In that way it is the linear, not in terms of the address. Each node contains at least two information. One is the link to the next node. Other one is the information field. To create this node, we have to make use of the concept of structure. A linked list are drawn as an ordered sequence of nodes with links represented as arrows. This is the arrow that you have to use it here. The starting point of the arrow is pointing to the source node. The arrow towards the nodes following it. The meaning is that you are going to put the address of the next node in the previous node. Point note here, the nodes do not reside in sequential locations. The address of this node or address of these nodes are not sequential. We don't know. This in the memory location may come before or maybe after the location. We can't guess the address of those nodes. And these address may change in different attempt of execution. So there is no constant address because it is allocated at the time of execution. So it is called dynamic memory location. A list elements are stored in memory in arbitrary order. We don't know where is the address, what is the address, which address is assigned. We don't know. It is decided at the time of execution. This has got two fields. One is the link field, other one is the information field. The link field has the address of that other node following it. With that we can traverse, can reach to any node. By step movement you can reach to any node. Other information is the data field. Let us take how actually that is represented in the memory. Part of the memory is given memory layout and I have to store the linear array called L having 5 elements of type character. So these elements are stored linearly. See, these many locations simply wasted. A result, some say 10 or 20 or 100 memory location, 100 bytes, 100 that size, that element. But I don't have. I don't have. So this is completely held by the program. The other part of the program or other program cannot access this one. It is locked. So we observed here the wastage. In case of list, linked list, it is arbitrary. The A need not be in the first place, C need not be in the third place. Some prelocations are given to those. Here, this doesn't mean that waste is a part, maybe with other program control. The first element, second element at the end, third element, fourth, fifth, like that. How that is linked? See, this is the first field. A is the first element. A has the address of B. B has address of third node C. C has address of D. D has address of E. E is not having anything. So the address field, the link field of E should be set to null because it is the last node of the linked list. What different operations we can perform? On linked list, we can start traversing each and every node, visiting each and every node. The operation is traversing. I can add a node. Then again there are three choices. I can add a node at the beginning place. I can add node at the end place. I can add anywhere in the linked list, that is a specified place. Adding at the beginning is called front insertion. Adding at the end is called rear insertion, and this is the random place insertion. Similarly, I can remove the first node, I can remove the last node, or I can also remove a specified node of the linked list. I can merge, I can sort, but for the time being, we'll see only the basic operations like traversing, insertion, and deletion. Let us take one example. Suppose this is a linked list. The list, the information field of the list has got string type of data, and there are four nodes. The first node address is a PTR. Now I have to insert one more node whose data is say mat. I have to insert it after cat, before sat. Very first step is I should acquire this particular node. The first step is to acquire it. This is the first step. Get a node which is not currently used by any program, any part of the process. So this is a free node acquired from by calling malloc or cloc function. Okay. Let its address a p address. P address is the address of newly created node, newly added node. PADD. The next step is what data you have to set it. To this link information field, I have to set the data. Say mat. Right now, this is null, or it can be garbage. The next step is set the address. I should set the link field of this one. With what? I have to set the link field of the node following this one. Suppose this is a node of interest P. This address I have to put it. What is the address of this one? The address of this is, say if this is P and the address is P of link, this field is P of link. P of link is this one. This is a link field. Actually that is a other node. This address actually is another node. Now what I have to set? As I don't have the name, specific variable name for this one, but I can make use of the previous node, that is P of link. So P of address, that P address of link field is P of link. We will be getting this one. So don't start this directly. You link, set the address field of the newly created node to point the next node after P. Now I don't want this link. For that I should hold the address of newly created node here. This is a thing. With this you can add node at the specified place. Now to add node in this place, first of all I should get new node. That new node name is PADTR. This is front insertion. I should set A here, that is the data field. Then I should set the address of this PTR here. If PTR is the starting point, the address of that I have to put it here, that is A of link equal to PTR. Right now this is the header node. I have to change that to header node. The next line that is required is PTR equal to A. The first line is A of link field. Suppose newly created node is P of link equal to PTR or header node, anything. Okay. Right now, this is the header. Now I have to change it to this one. That means ptr equal to, if ptr is the header node, ptr equal to newly created node. Let it be say p. These steps you have to write it. Then only when say that this is the starting point of the linked list. Now I have to add one more node. This is a newly created node. The name of this is say p, having data like x, and this is null. This is null. The data is say xy. What I have to do? Right now, the header is pointing to the first node. I should bring this to here. The first step is obtaining a node. Second step is set the link data. Third step, traverse and reach to the last node. Right now, assume that you have reached to this node. I will be taking that temporary pointer as temp. Headers here only. Temporary pointer temp. Then I have to link. I have to hold the address of p here. How? Temp of link equal to p. So in this we have seen anywhere insertion, insertion at the beginning, insertion at the end. These are the three different insertion operations. The next is how to acquire a node. I can call mloc function or cloc function. This can be used to add a new node. Whenever you want to remove a node from the linked list, you can call free function. In order to create this node in C, you make use of structure. The definition goes like this. Type def struct the field, what and all field that you are going to set. Can be any number of fields. Here I have taken integer type. Can be string, float, or even a structure also. This is generally it is information field. Other is the link field. That is a pointer. It holds the address of the next node. Remember that it should be given like this. It is a structure pointer. Structure name is list. Struct list. It is a pointer. So star link. This field name is the link, and the first field name is no. This is no. In this first node if name is p of no is 100 and p of link is 1550. If this node is p address is 1550 as per the above example, and p of information field, p of number, it is equal to, as you can see, 100 information field. Similarly, p of link equal to the address of the next node. The address of the next node is 1560. These three you can note down. Node name is P, whose address is 1050, 1550. The data field of that is 100. The link field of is 1550, which is the next one. This type of modification that is done in structure is called self-referential node, self-referential structure. It has got a special field, address field, which is of type same structure. Let us create a two-node linked list in C. First step is to define self-referential structure having one field, that is the link field. This is a link field. This is a link field. We need to create two nodes. Let it be pointer 1 and pointer 2. Pointer 1 is this one and pointer 2 is this one. ptr1 and ptr2. First, acquire the data, allocate the memory. Allocate the memory. As I don't want any garbage value, I can call cloc function. The syntax: one node I have to create of size node. Having created nodes, the next step is to set the value. I need 10 here, I need 20. So I have to set number field to 10 and second node number field to 20. Pointer 1, this is a PTR1, this is PTR2. PTR1 number field to 10, PTR2 number field equal to 20. After this step, after this step, it is just like this. One node is created, second node is created, having two fields. The first field is data and the second field is address. As it is CLF function called, both are null. It is not the linked list. Manually, you can add the address of the second node. The address variable is, what variable is ptr2 and this one is ptr1. What I do? I have to set link field of first one with the second one. The statement is ptr1 of link. ptr1 of link equal to ptr2. Other is, to ensure that we don't have any more node, you can use ptr of link equal to null. As it is a CLR, this statement is not necessary. If malloc is there, you have to use this particular statement. For CLR, it is not required. To access this statement, ptr1 of number 10 you will get, ptr2 of number 20 you will get. How to read data for a linked list? The first step is to create the node. We have got self-referential structure and we have aliased using typedef. The statement will be typedef struct list. This is the alias statement which is representing list. Typedef struct list. We have to create a node. You can use CLF function or you can use MLF function. I'm going to create one node of size this much. This is a node structure. This name is new node. Whenever in case of attaching a particular data to the linked list or inserting a node anywhere at the beginning or at the end, you have to call this function. You can call this function. Main purpose of this function is to create a node setting the data. Data entered by the user, let it be set 10. 10 is entered by the user. And as it is CLF function and null is set in the link field. This you have to return it. During insertion, you are going to call this. This is the purpose of get node. Purpose of get node is to create a node and setting the data value. Next is one of the simple thing, that is traversing. Assume that a linked list whose starting address say ptr or it can be p. Here I have taken the code p, it is a ptr. There are four nodes. There are four nodes in the linked list. Okay, and the last node link address is null. I have to print it. I can print only if node is not null. For that I have to check this one. Is this node is null? No, it is not null. If this is not null, take the data field. Suppose the linked list is having data 10, 20, 30 and 40 and the name of this is P. To access the data field, that information field P of number, because our structure has got field number. Next, having printed this, the next is to advance to the next node. This is a statement P equal to P of link, because link is the other field which holds the address of the next node. The address is, so it can be anything. To reach to that node, this one, repeatedly you do it. You put that inside while loop. With that you can visit all the node, hence the name traversing. Now how to add a new node at the beginning. It's also called front insertion. I can call this routine. I'll be sending the linked list, that header, and item to be added. Name of my linked list is head. Let it be say head. This is the head, head of the linked list. As usual, I have to acquire one node. I can use mloc function or cloc function. That is of type node. The first step is to acquire new node. Set data field. Set data field. For example, this is 10, this is 20, 30, 40, 50, like that. And the value that is set here is 5. The newly created node is new node. New node link field is pointing to head. New node link field is pointing to head node. Later, this is not the head node. This should be set as the head node. I have to bring this header to here. The name of the node is new node. I have to bring that head to here. That is, what is the head node? New head is our new node. Head equal to new node. In case of insertion, you modified something. That means linked list is altered. Return it. Return the head node. Same way, you can also insert node at the last place. That operation is rare insertion. So we need a linked list and data to be put in the newly created node. Let us take one temporary variable p. P is pointing to the head node right now. Suppose this is the first node, head node. P is pointing to head node. Acquire a node, can use mloc function or cloc function. Set the data field. Set the data field. For example, this is my new node. And data to be placed here is 50. This step is over. Now I have to bring this to here. How? Just check whether link field is null or not. Link field is null or not. P of link is not null, so go to this step. P of link is not null, go to the next step. P of link is not null, go to this step. P of link is null. That means you reached the end node. So after moving, head is same, but P at the last place. Once you reach to the last place, you have to set this link to point to the new node. That is P of link equal to new node. P of link equal to new node. Return the head. This is how you can insert at the rear place or front place. Now at the specified place, for example, if this node is name node, I have to add new node. Let it be temp node. Assume that node is the node. After that, a new node to be created. New node is a temp. As usual, obtain the memory, set the data. I have to point this one. Temp of next equal to this particular is node of next. In terms of previous node, I can represent that one. That is node of link. As it is having the address pointing to the next node, this node name can be node of link. So temp of link is to point to node of link. This is the statement required. So if you reverse, it gives the wrong answer. So this is having the address of the node following node. After that, you change the link to point to this one. How it is possible? Node of next equal to temp. Node of next equal to temp. With this, you can also insert data anywhere in the linked list. Given at least one information. We'll go for the deletion. You can delete the first node, the front node, or the last node. that is rare deletion, front deletion or rare deletion. In order to delete, we need the header information. Let header be the head. Node to be deleted is say P. It is a temporary. After removal, the head is right now head is here. After removal, the head should come here. That means it should advance. Head is head of next. The node that is deleted, you can display its earlier information or anything. As P is a deleted node, it is safe to call free function to put these free location to the pool of memory so that any other process can make use of this newly added memory location. Better to use link, otherwise those becomes a dangling pointer anyway. Better practice is to free up those unused node. Here in this case, after printing, after completion of specified work, P becomes the garbage. Use free state. P becomes the garbage. Call free statement to remove P. The next is to remove the last node. I need to have the information of the head node. I'll be storing the head node temporarily by P. Okay. Suppose this is the linked list having 5 nodes. I have to remove this one. Just check whether head is null or not. If head is null, head of next, because this is a scenario. This first one means a node is having a link field that is null. That means this is the case. Is head is null? Yes. Is head of link is null? Yes. When you remove that, it becomes the empty linked list. For that, this line is required. Otherwise, what to do? This is a temporary node. Check it whether it is next field is null or not. No. Go to the next. P equal to P of next. Is the link field is null? No. Go here. P of next is null? No. Go here. P of next is null? No. P of next is null. Okay. So you can delete it, but there is a problem. So that you cannot, that you can solve it in this way. Same, I'll take some 4 nodes and last node link address is null. This I have to remove. And the name of this node is head. I've taken this as P. Okay. Is P of next is null? No. You store this in variable Q and then move P. In the next round, is P of next is null? No. You store this in P and go to the next node with the P. Is P of next is null? No. Go to the next node P and this becomes Q. Is P of next is null? Yes, it is null. So node to be removed is P. Anyway, we have got the information of the previous node like this. So this is extra thing required. After that, remove the P node and return the head node. Thank you.